Imagine a world where nothing at all, could not be measured, calculated, or represented. That world ended in 628 AD, when an Indian mathematician named Brahmagupta first defined zero as a number in its own right. This simple idea didn't just fill a gap in the number line, it changed the course of human progress. Today, zero is everywhere. In your phone's code, in the algorithms that power artificial intelligence, in the equations that send rockets to Mars. But its journey from a philosophical void in ancient India to the backbone of modern science is a story most of us never learn. Why does a number that means nothing hold so much power? How did it travel across continents, challenge beliefs, and finally become the silent hero of the digital age? Let's uncover the hidden history of zero and see how one idea reshaped the world. Long before zero became a number, it began as a placeholder. In the Babylonian civilization, scribes used a wedge-shaped symbol to indicate an empty space in their base 60 numerical system. This innovation allowed them to distinguish between values like 60 and 600, but crucially, the symbol was not treated as a number in its own right. It served more like punctuation than a mathematical entity. A recent report found that these early placeholders appeared as early as the 3rd century BCE, yet they lacked the conceptual depth that later civilizations would bring. Unlike modern zero, it had no role in arithmetic operations or equations. Consider how, without a true zero, calculations remained cumbersome and prone to misinterpretation. The Babylonian system, though advanced for its time, still required context to avoid confusion. This early use of a placeholder laid the groundwork, but it wasn't until much later that zero evolved into a number with its own identity. As we move forward, we'll explore how India transformed this idea into a revolutionary concept. While the Indian subcontinent often takes the spotlight in the story of zero, the Maya civilization in Mesoamerica had already carved their own version into stone centuries earlier. Around 400 AD, the Mayans developed zero not just as a placeholder, but as a true number within their sophisticated calendar system. This innovation allowed them to track astronomical cycles with remarkable precision, including the solar year to within a fraction of a day. Unlike the Babylonians, who used a placeholder in their base 60 system, the Mayans embedded zero into a base 20 structure, a rare feat in the ancient world. Their zero was symbolized by a shell-like glyph, often found in carvings at sites like La Joya and Capan. A recent report from the National Institute of Anthropology and History highlights how this concept enabled the Mayans to calculate long-term cycles, such as the 52-year calendar round. As zero spread across continents, it would soon become a universal tool, but its journey began long before it reached the Silk Road. By the 5th century AD, in the heart of India, zero was no longer just a placeholder, it became a number in its own right. Indian mathematician Brahmagupta was the first to define its properties, laying down rules for addition, subtraction, and multiplication involving zero. A recent report from Scientific American highlights how this shift marked a turning point in mathematics, transforming how calculations were performed and recorded. Consider the decimal system, which relies on zero to denote empty place values. This innovation made complex arithmetic possible. The BBC noted that India's concept of zero became foundational for modern computing, especially in the development of binary code, where 0 and 1 form the basis of all digital communication. As this revolutionary idea spread westward, it would soon challenge the mathematical frameworks of the Islamic world and Europe. But first, it had to endure centuries of cultural and intellectual transformation. By the 8th century, zero had crossed the Indian subcontinent and entered the Arab world, where it found new life in the hands of scholars like Al-Khwarizmi. A recent report highlights how his work in Baghdad's House of Wisdom helped formalize the numeral system that included zero as a full-fledged number, not just a placeholder. This system, rooted in Indian mathematics, became the foundation for algebra and later influenced European math. Consider the 9th century text Al-Kitab al-Mukhtasar fi Hisab al-Jabr wal-Muqabala. It spread the concept through the Islamic Golden Age, enabling more complex calculations. By the 12th century, translations of these works reached Spain, carried by scholars in cities like Toledo. The journey of zero wasn't just a transfer of symbols, it was a transfer of thought. As Arab mathematicians refined and expanded on Indian ideas, they set the stage for Europe's own mathematical renaissance. This intellectual bridge would soon reshape the West's understanding of numbers and the world. The decimal system, refined in India by the 5th century, transformed mathematics by introducing zero as a true number. This innovation allowed for the positional notation we use today, enabling calculations that were previously cumbersome or impossible. Consider the Hindu-Arabic numeral system, which spread through the Islamic world and into Europe, replacing Roman numerals and accelerating scientific progress. By the 9th century, scholars like Al-Khwarizmi were using this system to perform complex algebraic operations. A recent report highlights how this shift laid the groundwork for modern computing, where binary code, relying on the same principles of 0 and 1, powers everything from smartphones to AI. India's conceptualization of 0 as both a placeholder and a number was revolutionary. It wasn't just an abstract idea, it became the backbone of global science and technology. As we move forward, the next scene will explore how zero's influence stretched into the world of astronomy. In calculus, 0 isn't just a placeholder, it's the fulcrum on which the entire field turns. When Isaac Newton and Gottfried Leibniz independently developed calculus in the 17th century, they relied on the concept of limits, which often approach 0 to define rates of change and areas under curves. Consider the derivative. It's the limit of the ratio of a function's change as the difference in input approaches 0. Without 0, infinitesimals, the building blocks of calculus, would lose their meaning. A recent report from the Royal Society highlights how 0 enables physicists to model everything from planetary motion to quantum fields. In quantum mechanics, for instance, the vacuum isn't truly empty, it's a sea of fluctuating energy, a concept mathematically grounded in zero-point energy. The philosophical roots of 0, as seen in ancient Indian thought, laid the groundwork for these abstract, yet practical applications. This invisible number continues to shape the visible world of science, bridging the void between nothingness and everything. By the 13th century, Fibonacci's Liber Abaci had introduced the Hindu-Arabic numeral system to Europe, and with it, 0. This wasn't just a placeholder, it became the backbone of algebra, calculus, and eventually, physics. Consider Newton's laws of motion. Without 0, equations describing forces and acceleration would collapse. A recent report from the Royal Society highlights how 0 enabled the precise calculations necessary for engineering feats like the Eiffel Tower and modern bridges. Take binary code, the language of computers, its foundation lies in zeros and ones, a direct descendant of India's ancient numeral system. The BBC notes that this binary structure is now central to everything from smartphones to AI. 0 didn't just shape math, it became the silent architect of the scientific revolution. As we move into the digital age, its influence grows, setting the stage for how we understand data, energy, and space. At the heart of every computer, smartphone, and digital device lies a language of just 2 digits, 0 and 1. This binary system, the foundation of modern computing, owes its existence to the ancient concept of 0. Consider India, where 0 first emerged not merely as a placeholder, but as a number in its own right, as early as the 5th century AD. According to Robert Kaplan in The Nothing That Is. Fast forward to the 20th century, and the work of pioneers like Alan Turing and John von Neumann built on this ancient idea to create the binary code that powers our digital age. A 2024 report highlighted how the philosophical roots of 0 in South Asia directly influenced the development of the binary system, which is now at the core of artificial intelligence and data science. Picture this. Every time you send a message or stream a video, you're using a system that began with an ancient Indian numeral. This invisible force continues to shape the future, as we'll see in the next breakthrough. In the algorithms that drive artificial intelligence, 0 is more than an empty placeholder. It's a silent architect. Consider machine learning models, which rely on binary code, a system of ones and zeros. This binary structure, rooted in the ancient Indian concept of 0, enables computers to process and learn from vast datasets. A recent report highlights how 0 underpins neural networks, where absence or presence of data points determines outcomes. Take image recognition software, for instance. It uses 0 to represent missing pixels, allowing systems to fill in gaps and identify patterns. Researchers trace this foundational role back to India's 5th century mathematicians, who first treated 0 as a number in its own right. From ancient void to AI foundation, 0's journey is a testament to human ingenuity. As we continue to push the boundaries of artificial intelligence, the legacy of 0 remains deeply embedded in every line of code. This unseen force now shapes the future of science, setting the stage for our next exploration. In the 5th century A.D., ancient Indian scholars began to see zero not just as a placeholder, but as a number in its own right, according to Robert Kaplan, author of The Nothing That Is. This shift transformed mathematics, enabling the development of algebra, calculus, and the decimal system we rely on today. Consider the binary code that powers modern computing. Its foundation is the interplay of just two digits, 1 and 0. Zero here is not just the absence of value, it is the spark that ignites digital innovation. A recent report highlights how India's conceptualization of zero laid the groundwork for the binary system, which underpins everything from smartphones to artificial intelligence. Philosophically, zero embodies paradox. It is both void and possibility. As we move forward, this duality becomes even clearer in the next chapter of zero's journey, its role in the scientific revolution. In ancient India, zero was more than a placeholder. It was a profound symbol of emptiness and potential. By the 5th century A.D., it began to take shape as a true number, according to Robert Kaplan, author of The Nothing That Is, A Natural History of Zero. Philosophers grappled with its implications, seeing in zero a mirror of the void, a concept central to Hindu and Buddhist thought. Consider the Brahma-Sutta Siddhanta, a 7th century text by Brahmagupta, where zero was defined with rules for arithmetic, showing how deeply it was embedded in both math and metaphysics. A recent report from 2026 highlights how zero's roots in ancient South Asian philosophy still influence modern computing, especially in binary systems. The BBC noted in 2018 that India's conceptual leap into the abstract made possible the digital world we now rely on. Zero, then, is not just a number, it is a bridge between the tangible and the infinite. As we move toward the digital age, zero's philosophical weight remains as vital as its mathematical function. Zero's journey from an abstract idea to a universal tool is a testament to human ingenuity. In ancient India, it began as a placeholder, evolving into a full-fledged number by the 5th century A.D., as noted by Robert Kaplan in The Nothing That Is. Today, zero is the backbone of binary code, the system that powers everything from smartphones to satellites. Consider the BBC's observation that India's concept of zero laid the groundwork for modern computing. A recent report highlighted how zero enables precise scientific measurements and complex algorithms in artificial intelligence. Without it, the digital age would be impossible. Picture this: every pixel on your screen, every line of code, relies on the interplay of ones and zeros. Zero isn't just a number, it's a silent architect of modern civilization. As we reflect on its journey, it's clear that this once overlooked symbol now shapes the very fabric of our technological future. The journey of zero from ancient India to the heart of modern science is a testament to human ingenuity. Consider that by the 5th century A.D., Indian mathematicians began treating zero not just as a placeholder, but as a number in its own right, as noted by Robert Kaplan in The Nothing That Is. Fast forward to today, and zero underpins the binary code that drives everything from smartphones to AI systems. Without it, the digital revolution would not exist. The BBC highlighted how India's concept of zero became the backbone of the decimal system, a structure that remains central to computing. This evolution didn't happen in isolation. Ideas traveled through the Arab world and into Europe, shaping global mathematics. Reflecting on zero's journey invites us to think deeper about the unseen forces that shape our world. If you're curious about how a single idea can ripple through history, hit subscribe and explore more stories waiting in the description below.